In this video, we are going to look at solving equations. We are going to look at solving equations using the Desmos calculator. Okay, so you're going to want to have that open while we're going through the examples in this packet. Okay. To find the solution to an equation using Desmos, we're going to find the intersection points for each side of the equation. So what we're going to do is in the first line, we're always going to put y equals. So let's circle that. You're always going to put y equals, and then the left side of the equation, we only want to use x. So if there's an a, b, or a c, we want to replace that with x. We're going to do the same thing in our second line. We're going to type y equals, and then whatever's on the right side of the equation, again using x for any variables. Then we want to click on the point where the two lines intersect. Okay, so two lines are going to touch, and that point is your solution. The solution is going to be the x value of that point. If we can't see the intersection point, we can use the zoom in and zoom out features on Desmos. So let's take a look at what this might look like with a real problem. So example 1 says, what value of x makes this equation true? So that's kind of a longer way of just asking what's x. So you can solve this by hand, but we can also go ahead and pull up our Desmos graph, and we can go ahead and type it in. So in my first box, I want to type in the left side, but remember we want to put y equals first. So we're going to do y equals, the left side says 3x minus 20. So that's the line for our left side. Then we're going to do our right side. Our right side said negative 2x, so I'm going to write y equals negative 2x. And I'm going to come over to my graph now. And I don't see anything in this picture, but here I can't see the intersection. So we can zoom out, okay? And you can also grab it and move it around, okay? So we're looking for where the 2 points touch, and we can see that occurs here. It says 4, negative 8. So our solution is going to be the x value, which is 4. So I'm going to come back to my page and check my multiple choice. And there is 4. So again, I did y equals this side of my equation, so 3x minus 20. And then I did y equals this side of my equation, which was negative 2x. And when I typed those in, I got the coordinate point for negative 8. Okay, and I want to look at that x value. That is my solution. Okay. So again, we're going to do the same thing for number 2. It says solve the following equation for m. Now, we said before we never want to have anything other than x when we're trying to solve. So instead of m, I want to find out what x is. So I'm going to change m to be x. Okay. So I'm going to come back to Desmos. I'm going to get rid of my other equations, and I'm going to type this one in. But instead of m, I'm going to put x. So 3x minus 2, okay? What you can do is you can highlight this and then click divided by 5. We always want to have y equals, so we can go back there and type in y equals, okay? And then we're going to do it for the next one. It says 7 over 10, so I'm going to write y equals 7 divided by 10. Okay. And now again, I want to look at where they touch. I'm a little zoomed out here. It might help if I click the plus sign so I can see where they exactly touch. Okay. Now again here, so I'm always looking for that x value. So that's that 1.833. So I can come over here and say that m is going to be equal to 1.833. But I look at all my answers and they're all in fractions. So I need to see which fraction matches this decimal. So go back to Desmos, and I'm going to type in my first answer, which says 6 over 11. And I see that they don't match. Okay, I'm looking for that 1.833. And then my multiple choice B says 11 divided by 6. And there it is, 1.8, and then the 3's are repeating. So that is going to be your answer there, choice B. Okay. All right, so let's take a look at our next example. This one says solve for n. Remember, whenever it says a letter, we're going to cross that out and put x. So I'm not looking for n here. I'm going to actually look for x. Okay. So this time there's no multiple choice. Okay. But we're going to do the same thing. We're going to come to our Desmos, get rid of what we had, clear it all out, start fresh, and we're going to type in the left side, y equals, okay, 6x minus 14. Again, we can highlight it. I want to highlight all of it, divided by 6. And then my other side, y equals 2x plus 5, all divided by 3. Okay. And now again, if I click on my graph, I can't see the intersection, but I can tell that these two lines are going towards each other. So I'm just going to move this up. There's where they touch. It might help if I zoom in a little bit more. And then I can click, see if I get a good point there. So I have 12, 9.667. I only want my x coordinate there. So it tells me I know that x is equal to 12, but this actually asked for n. So we really want to know that n is equal to 12. That's our final answer. Okay? So that's how we can solve equations using Desmos. Sometimes you might also be asked for some word problems, and we'll talk about word problems some more in later videos, but with linear equations and solving equations, there might be a word problem you have to translate into an equation and then solve it. So when you're doing that, you want to look for keywords. They might be each, every, per, and an are just a few of them, okay? These all mean multiplication when you see them, okay? And the corresponding number will be next to the variable. So if you see something that says $4 per hour, that would translate to being 4 times x, or 4x, because we're earning $4 for every hour, okay? So we're multiplying 4 times the hours. So let's take a look at an example. It says for babysitting, Nicole charges a flat fee of $3 plus $5 per hour. It says write an equation for the cost C after H hours of babysitting. So I'm looking for the cost. So cost is going to be equal to, we have a flat fee $3 plus $5 per hour. So there's that multiplication. You could also write it C equals 5H plus 3. These are the same thing. Okay, the order doesn't matter here. Okay. If you want to go ahead and flip your packet over, we're going to look at one more example here. So these are literal equations. Literal equations are when we're going to rearrange and solve for a specific variable. So for these, we're going to use inverse operations to isolate a given variable. Okay, so we have our reverse order of operations that we're going to do. So example 4 says, a data set with an even number of data points is ordered from least to greatest. The middle two data points are represented by x1 and x2. This formula can be used to find the median of the data set. So they give you a lot of information there, but they're really just asking, based on this formula, which shows this formula solved for x sub 1. So they want to know, here's this formula. Okay, I want to know what it would look like if x sub 1 was on the side with the equals. So if you notice, all your answer choices have x sub 1 equals. So that's what we're trying to do. So if I look at this problem, I want to get x sub 1 by itself, but all of it is over 2. So I've got to do my opposite operations. I see this big division bar, so I'm going to do the opposite of division, which is multiplication. I'm going to multiply both sides by 2. So I get 2m is equal to, now the 2's over here will cancel. So I have x sub 1 plus x sub 2. But again, I want to get that x sub 1 by itself, and it's still being added by x sub 2. So I'm going to subtract x sub 2 from both sides. In literal equations, you're not going to have a lot of like terms. If you notice, these are all different letters. These are not like terms because of the 1 and 2. So that will cancel, And here, these are not like terms. So we're going to get x sub 1 is equal to 2m minus x sub 2. Okay, and then I'm going to look at all of my answer choices and see which one matches. And it looks like answer choice B is the one that matches. We've reached the end of our examples. Please now continue on to the practice problems in your packet.